All right, everyone, back again. This is our final example. And this time we're just going to look at this not just from a numerical perspective, but also from a graphical perspective. So we're going to branch into, and this will be the beginnings of us looking at not just evaluating limits from a numerical perspective, but also looking at the picture. Sometimes looking at the graph ends up being an easier analysis, but if we don't know the graph or have access to technology, like if we don't have access to our graphing calculators, then the graphing part is going to be harder to analyze. So that's why we always start off by looking at numbers. So we have here is limit as x is approaching 0, and our function is 1 over x squared. So again, we are approaching 0. So this is a prime example of if I just kept thinking that limits were just me plugging in the number, I would have plugged it in and I would have said, oh, it's undefined. But that's not the answer. We are approaching 0. So again, I'm going to set up my table, and I want to see what happens as I come from the left, and then also as I come from the right. So I'm going to come from the left of 0. So that means small negative numbers. So negative 0.1, negative 0.01, negative 0.001. So I picked this function in particular just because it's symmetrical. So even if I plug in the positives, I'm going to be getting the same answers. So I'm going to be kind of doing it in unison here because they'll yield the same answers just because it's x squared. Okay? Not every function's like that. That's why I picked this one as an example to do, just to make it easier for us to see, and I can get to the graph. So I do 0.01. So 0.01. Oh, sorry, 0.1. I'm going to square that. So and I get the answer of 100. So if I do it negative or positive, the answer is 100. Now if I go closer, so 0.01 squared, okay, so 0.01 squared, I get 10,000. So I'm looking here and I already see, whoa, big jump. All right, let's keep going closer. Maybe it's approaching an actual value, but if you already kind of know what this does, you would see that, yeah, that's not going to be the case. But one too many zeros on that last one there. My calculator. Okay, so now we got is a million. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So when I come from the left side of this function, this is increasing very, very fast. It does not seem to be approaching an actual number. It's just getting larger and larger. So I would say that if I'm coming from the left, it's approaching infinity. Now, infinity is not a number, okay? I'm gonna put that up here. So infinity is not a number. Okay, infinity is a concept. We cannot encapsulate infinity. So we cannot say, hey, I got to infinity and that's the end of the road. Infinity keeps going and going. So that's what is going to keep happening here. This is just going to continue to grow and grow and grow without bounds. So it's approaching positive infinity. On the other side, I see that same trend. It is approaching also positive infinity. So when I look at both of my, so both sides of the limit, I do get an agreement. We are agreeing that we're going to head to this exponential, not, I don't want to say exponentially. We see that we're approaching this incredibly large number. So it's not like one side is approaching a large number and the other side's approaching a different large number. We're approaching is infinity. So therefore, there is agreement. And I would say that as I approach 0, this this function is approaching infinity. Now, it's not a number, but we are in agreement with where we're going. So if I were to make a sketch of the graph, and you can put this in your graphing calculator, and you can visually confirm that that is true. So I'm just making just a hand sketch here. So the graph of x squared looks like this. This is 1 over x squared, sorry. So as I approach 0 from either end, I see that I am in agreement. We're heading to infinity. As I get infinitely closer, this is just going to keep jockeying further up. So will it do on this side? And I would get infinity. Now, as a quick addition to this, what if the function were just 1 over x? Well, if it's 1 over x, now that's a different story. So if we were to change this up, and I had graphed one over x, I know that 1 over x, 1 over x looks like this. So if I asked, hey, as we approach 0, what's the limit of 1 over x? This would be does not exist. Because as we come from one side, I would have said, oh, it's approaching negative infinity. This is just going to dive further and further down. While on the other side, I see what? Oh, I would be approaching positive infinity. We are not heading to the same number. Okay? So it's not like all of a sudden magically this is going to, dive down and catch up with this one, or this one's going to zoop, pop up here and match with that one. It does not exist. All right, so that ends it for our examples here. So if you're still stuck for whatever reason, feel free to send me an email, bring it up in class as well. So these short little videos are just designed for you guys to kind of watch before you look at the material in the book, before you dive into the problem set, just as kind of an icebreaker into what we are talking about. All right, and I will see you guys next time.